give charge plus Q and minus Q. These are the plates of capacitor. I given a charge plus Q minus Q. What will happen to this charge? Where do it will get deposited? So that positive charge will deposit here, and the negative charge will deposit here. This is what happens. So what is the capacitance? So this having the area of cross section of plate C. So how you define capacitance? Epsilon naught A by D. Agree this? So what is the charge of capacitor? Net charge of capacitor is 0. Net charge of 0. That's all, no? What is the charge? Plus Q minus Q. So, but charge of capacitor means what I should say? Charge of capacitor. What should be the, how we should define it? Charge on inner surface of positive plate is defined as charge of a capacitor. Net charge of capacitor will be 0. There's no doubt. But in the formula, when we write V equal to Q by C, what is this Q? The charge on inner surface of positive plate is called as charge of capacitor. I don't write Q minus Q are 0. No, not like that here. In fact, there's a potential difference is there. So what is Vxy? So Vxy, we are going to write it as Q by C, not Q net by C. So there's a small basic thing. So instead of giving charges, let me give charges of this kind. If you give charge Q1 and Q2, instead of giving equal and opposite. Then what I do, I will bring a circuit. There's like a switch. Later on we'll see what all happens here. There's a X, there's a Y. Plate X, plate Y. Now, what charges will be there? So previous problem open, the plates are the plates X and Y are given charges Q1 and Q2. So he's asking find the charge of capacitor. Okay, what to do? We know electrostatics. Go back to the Gauss law. So final charge distribution, how it will be? So this is initial. I'll go for one more diagram. It'll be easy for you. What will be the charge distribution on the each surface? Plates, it will have two surfaces. Then I'll close switch in the end after getting the values. These are the terminals. This is X and Y. Okay, come for this. This charge should be Q1 plus Q2 by 2. This is how much? Q1 minus Q2 by 2. And this will be, okay, this will be the charge here. So what is the charge of capacitor? So which plate is a higher or lower potential? Who will tell the electric field between the plates? How the electric field between the plates? We know it will be directed like this. So how do you can see? I think you know from the Gauss law, this is the positive. The charge here will be positive. Here also positive charge will be deposited. here it will be negative charge if you check it, and here it will be positive charge. So the net field between the plates will be towards right. And we know the from electrostatics, the electric will be directed from higher to lower potential. So which plate is at higher potential? Vx will be greater than Vy. What is the electric field expression for electric field? Q1 minus Q2 by 2 by A by epsilon naught. This is the charge density, no? Can we calculate potential difference? Yes, it is. Then what is the charge of capacitor? Charge of capacitor is Q1 minus Q2 by 2. The charge on the plate X is positive plate. Plate X what happen will become positive plate. So charge on inner surface of positive plate should be Q1 minus Q2. So what is the charge of capacitor? So charge of capacitor is Q1 minus Q2 by 2. How to calculate potential difference? As we have a formula, E into D. We know value of E, substitute here. You see that I just didn't say theoretically, I have enough proof. Now Q1 minus Q2, this will be epsilon naught A by D. So what is Vxy is equal to now? Charge by capacitance. So F naught A by D will be capacitance of this. So see now, in place of Q, what you got? Q1 minus Q2 by 2. So therefore, the charge of capacitor should be the charge on inner surface of positive plate is what? The charge of capacitor. Got this idea now? So even if you don't give, if you give unequal charges, yes, we can do it, but practically not possible. It's very difficult to construct a system like this, which is possible. This one is possible. How can we give such a charges? Just by connecting capacitor across a cell. Getting the idea now? So that's why in the books what happen, we have maximum problems based on this particular discussion only. This is a electronic engineer will not accept all this, but in books they have brought a problem, they made all, so you may feel very attractive, but electronic engineer will just laugh on it. Who the hell will going to construct such a circuit? That's why if you look at the standard books, no, they didn't bother to discuss all this. You take Resnick, no, he didn't bother because it's a stupidity. To give charges like this is stupidity. That's what they call. That's why the standard books, no, Resnick and they all, most of the electrical engineering books, no, they didn't bother. But you come to the our books, no, they made a very nice numerical everything. So definitely will be in somewhere giving wrong idea. This is practically not advisable. It's very difficult. It'll be very costly to give charges like this. See, to give charges like this, we have to invest lot of money. To give equal and opposite charges, plus Q minus Q, very easy. Just go and connect across cell. What is cell? 5 rupees available in market, or Duracell very costly, 20 rupees. Connect that Duracell across capacitor, so no. But something Q1, Q2, yes, it may up to 3, 4, 5,000 it will cost you. Tell me, unnecessary, you are wasting your money, no? Practically not advisable. A teacher like me will make problems like this. What you are seen on screen, no, teachers like us what happen to just impress a student, something new problem, no, they just bring, but this is something should not advisable, practically not advisable. Why not advisable? It will be unnecessary, it will make it very costly. See, cost is very important in science and technology. You can't just bring high cost things. Whatever the heat generated, I'll close the switch. So we'll move to the next part of the problem. Heat generated. After closing switch, how much of heat will be generated? what charge will flow here? Only the charge on inner surface of plates. So after closing switch, so what do we get is this charge will remain as it is. You see now, you definitely, so what happened, the field inside the capacitor will be 0, Vxy 0, Vxy 0. What is the electric field inside the capacitor? Was 0. So earlier there was some energy, no, in the capacitor. So what was that energy? Let's calculate that energy in the capacitor. Should be equal to any formula, energy density formula, UD into ED. So we know electric field value. So this should be equal to epsilon naught E square A into D. So this should be epsilon naught AD by 2 Q1 minus Q2 by 2. What was energy now? So this should be equal to Q1 minus Q2 whole square by 8A epsilon naught D. Okay, this much. This is the energy in the circuit here. So now after closing switch, I'm asking what is the heat generated? What all the energy in the capacitor is what will be heat generated across the resistor. So this what? Energy of capacitor or energy between the plates of capacitor. Energy between the plates of capacitor. And now what will happen to after close all that positive charge? So what actually happens? So now you can question like, so where do this charge gone? So let's go back to this circuit. Which plate is at higher potential? Vx greater. Go back to again electrostatics because the net field between the plates is towards right. So Vx greater than Vy. Okay, then like if you give a path for the flow of charge, the charge will flow from higher to lower potential. So therefore the charge will start flowing like this. How long this flow of charge will occur? As long as there is a potential difference. So all when this charge comes here, finally it will become 0. No, why can't this charge will flow? It's over permanently. It will be there. You can't bring it back. So finally, which charge has flown? Only the charge between the plates has flown to the resistor. So what is the heat generated across the resistor? Heat generated across the resistor R should be equal to H should be equal to U. What happened here? Here there'll be energy, no? There'll be energy. External to plates also there energy. So what will happen to that energy? That energy will be present there only and we can't take it back. So therefore tell me like now, what is the main purpose of capacitor? What is the purpose of capacitor? It's a energy storing element. Why do I use it? To store energy. Like I said, bucket. Why do we use bucket in bathrooms? To store water. And what do you mean by storing like a system? If you give it, it should store it, and whenever you want, it should return back. No, there's the meaning of storing. See, consuming is something, or sink. What is sink? Once you give it, okay, it not return back. Source as it will supply. What do you mean by store? If you give it, it will store it, and whenever you want, you should take it back. No, so suppose you have a bucket in bathroom, you pour water, and if you are unable to take it back, you should not call storing element bucket. It's a sink you have to call it. So what is a capacitor? It's an energy storing element. And what is the property of storing element? Whenever you want, you can add energy, and whenever you want, you can take it back. So here you look at this one. I added energy, but this energy added what when a part was there between the plates, a part was lying external to plates. But when I want to get back energy, which energy I got back? I got back only the energy between the plates. This energy open got wasted. Okay, let's go for this particular thing. Now come for this particular thing. So here I gave energy. What all I did work. So where do that energy gone? It is available between the plates. Now you connect this plate to the external circuit. So here I'll introduce now this plates. If I connect to external circuit, what conditions will arise? Okay, we know there's an electric field between the plates. There's a best conceptual part of the capacitor. Why only you are giving positive negative charge? There's a best discussion. So after closing switch, what happened? After closing switch, the whole energy in the capacitor now is available across the it. So what is H is equal to Q square 2C. The whole energy of the capacitor got converted. So this, if you want. So from where this energy to capacitor came, excitation does work to put charges plus Q minus Q. Then energy is there in capacitor. This whole energy of capacitor between the plates now is available across the resistor. You see, what was the energy of capacitor here? You know enough now. The whole energy is available across resistor. Now tell me like where I can get back the energy of the capacitor fully. Means here I did work to put a charge in capacitors. Now the energy is there between the plates. What all I do work is energy there between the plates only. So I'm able to get back the energy between the plates. What about here? I did work to put charges. A part of my mechanical work then is available between the plates and external to plates. If I want to get back, which energy I'm going to get back? Only the energy between plates. Tell me like, is this efficient? No, it's unnecessary. We lost some energy, which is permanently lost here. So therefore, this way of energizing capacitor is a not economical, practically not advisable. I just wrote one very powerful statement. Practically not advisable. Sir, what do you think? Unnecessary or lost energy here, external and energy external to plates open cannot be utilized for any application. So therefore, this is the wrong way of energizing a capacitor. That one. Only we have to follow this particular thing. So how to give this plus Q minus Q? Just connect across the cell, problem solved. So go this one. So which energy is useful for application? Energy between the plates. So I'll write that a very, so you can say, powerful statement. Energy confined between the plates is useful for